Imagine flipping a coin 5 times in a row, and every single time it lands on heads. You might start thinking, okay, tails must come next, but the truth is the chances are still 50-50, and you have just fallen for the gambler's fallacy. The gambler's fallacy is the mistaken belief that when random events occur in a streak, the opposite outcome becomes more likely. In reality, that is not true. The gambler's fallacy tricks people into thinking that random events are related, but randomness doesn't care about the past, the odds remain exactly the same. So why do we fall for it? Our brains are wired to search for patterns even in completely random sequences. It feels wrong to see streaks even though they are perfectly normal in randomness. On top of that, we tend to assume small samples represent the big picture. If we see a streak of one outcome, we expect the opposite to balance it out. This is why gamblers keep doubling down, convinced their luck is about to turn. But beyond the casino, the gambler's fallacy shows up even in professional settings like courtrooms and job interviews. A judge who has denied several applications in a row might feel that the next case would be stronger. A hiring manager who has rejected several candidates might feel that the next one would be better. It's therefore not a surprise that taxi drivers can also fall for the gambler's fallacy. In their daily work, drivers receive booking requests from passengers through an in-taxi terminal showing estimated time to arrival options 2, 4, 6, or 8 minutes, along with the passenger's location and ride fare. The drivers must quickly choose an option to bid for the job. Once selected, the passenger sees the estimated time to arrival and can decide whether to cancel, influenced by various factors including this wait time. This high-frequency, high-stakes decision environment is the perfect setting for the gambler's fallacy to creep in. To investigate, Professor Ivan Peng and Wang studied decision-making by taxi drivers in their paper titled Gambler's Fallacy Biases Taxi Drivers' Sequential Decision-Making. Firstly, they performed a retrospective analysis of more than 32,700 taxi drivers collectively serving about 9.2 million rides. They found that the taxi drivers were more likely to serve a booking if their previous job was a booking and cancelled. But whether a booking gets cancelled or not is random. The data suggests that the taxi drivers believed in the gambler's fallacy. If the previous booking was cancelled, they believed that the next booking would be less likely to be cancelled and bid more aggressively. To validate this interpretation of the data, Peng and Wang conducted a lab-in-field experiment. Student surveyors interviewed over 500 taxi drivers at Changi Airport and food centres like the Geylang East Food Centre, amongst other places. Participants in the experiment were randomly assigned into two conditions: control and tutorial. For both the control and tutorial groups, before the bidding scenario, participants were presented with the outcomes of two hypothetical series of 5 coin tosses. For instance, hits, 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 and hits versus hits, 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 and tails. They were asked which was more likely on a 5-point scale, that is, A is much more likely, A is more likely, A and B are equally likely, B is more likely, B is much more likely. The question was posed 4 times with different coin toss scenarios. These questions aim to elicit the driver's beliefs about the gambler's fallacy. For the tutorial group, they were additionally administered a brief debiasing tutorial after the coin toss questions. The surveyor read from the script as follows. The correct answer to all the questions is A and B are equally likely. The coin flips are independent, that is, the outcome of the previous flip does not have any effect on the outcome of the next flip. Any sequences of 5 outcomes is equally likely to happen. Both the control and tutorial groups were then posed the bidding scenario. Each subject was told the previous job was a booking, which had either been completed or cancelled. This was randomized. Then they were presented with a new booking from a passenger 5 minutes away. The subjects had to decide whether they wanted to bid for the booking, and if so, how soon they would pick up the passenger 2, 4, 6, or 8 minutes, just like the rear-in taxi system. The results revealed an interesting pattern. Those who believed in the gambler's fallacy picked a sooner ETA if the previous booking had been cancelled. They seemed to believe that the next booking would be more likely to succeed and so bid more aggressively. Importantly, this behavior was corrected by the tutorial. Amongst gambler's fallacy believers who received the tutorial, the outcome of the previous booking did not affect the bidding. Also importantly, there was no such pattern among subjects who did not believe in the gambler's fallacy. In sum, the research by Dr. Ivan Peng and Wang sheds light on how the gambler's fallacy subtly affects decision-making, even affecting taxi drivers with many years of experience. Therefore, when making decisions at work, in investing, or personal decisions, remember to avoid the human tendency to find patterns in randomness, the assumption that small samples represent the big picture, and the gambler's fallacy.